Okay, this video is the basically big trig section of this unit, and I'm trying to make the less videos that are a little longer so that it's a lot easier for you guys. Everything's compiled more together. And for that reason, I'm going to try to talk really fast. I'm going to try to talk really fast because I have a lot to cover in this video. So, let's remember, I think I told you guys to remember this a lot units ago because I said it would come up in this class. Well, now it is. You remember that the cosine of 2x, the double angle formula is from pre-calc, that the cosine of 2x is the same thing as 2 cosine squared x minus 1 and 1 minus 2 sine squared x. Well, by doing algebra, then you can solve that cosine squared x equals 1/2 plus 1/2 cosine of 2x, and that sine of 2x equals 1/2 minus 1/2 cosine 2x. So I hope you guys get this. This is kind of just like a precursor to this video, that you need to remember that that's how that algebra is going to work. And you could just do the work every time, or you could just kind of memorize that the sine one is going to be negative and the cosine one's going to be positive. Why do you have to know this? Well, now it's time that they're going to be asking you for things such as this. What is the antiderivative of cosine squared x? Well, to do this, you would just plug in the things that you know from pre-calc, and you would know that this is the same thing as saying the antiderivative of 1/2 plus 1/2 cosine of 2x, and you know how to do that. The answer would just be 1/2 x plus 1/4 sine of 2x. I don't know why it's going to be really long time. The x, or not the x, I'm sorry, plus c. I'm like super tired right now, I'm sorry guys. Plus c. That right there is the antiderivative of cosine squared x. So now that you know that, what if they asked you for something along the lines of this? Cosine cubed x dx. So this is going to get into kind of a messier situation, but using this, you can kind of take the antiderivative of any trig value to any exponent. So I think we can all say that this is the same thing as saying cosine of x times cosine squared x dx. Then we can substitute out that cosine x times, well, we know that there's a Pythagorean identity here, that cosine squared x is the same thing as 1 minus sine squared x dx. Alright, and by knowing that, we know that we can actually do a type of U-substitution here. Because we can say, well, if U equals cosine of x, right? Oh, I'm sorry, it's just sine of x. I'm spacing out. If U equals sine of x, then du would equal cosine of x dx, which we have here. So therefore, now you're left with 1 minus u squared du. Because these two things are going to be the du, and it's going to be 1 minus u squared. And then we know that this is the same thing as u minus 1/3 u cubed plus c, which equals sine of x minus 1/3 sine cubed of x plus c. Okay, so basically what I just taught you is how to use trigonometry and integrate. So just remember, the first thing I taught you in this video is called power reducing, and now what we're doing is kind of a trig, I don't know, identity, integration, antiderivation, I don't really know. So using this, we're just going to, I'm going to show you actually a sheet that you might want to write down all the stuff. It's super helpful. And it's basically how what we just did was we found antiderivatives by saying, if, I can't see if you can see this, but that if you want to get like sine of x and something in terms of cosine of x, because then if you make your u cosine of x, the derivative that's sine of x, and then you can do u substitution. Here are the other ones you want to do that for because of the derivatives and antiderivatives that coincidentally work out. So, the one last one I'm going to do in this video, wow, I succeeded. This actually isn't the longest video I've ever made. Is what if you have the antiderivative of secant cubed of x tangent cubed of x dx. Okay, so we know that the derivative of tangent of x is secant of x tangent of x. So we kind of want to pull out a secant x tangent x, because then that will be our du, because you'll see why in a second. But you basically, because remember how we just talked about how you want this and then something that's in terms of tangent of x so that you could do U-substitution. That was on the sheet I just showed you. But it's kind of similar to what we just did with the cosine cubed one. So if you did this, you would be left with a secant squared x tangent squared x. But we do know that secant squared x is the same thing as 1 plus tangent squared of x. Sorry, my phone just went off. I'm sorry, give me 1 second. Yeah, okay, sorry about that. So anyway, you're left with 1 plus tangent squared of x, and this is then times tangent squared of x. Oh wait, what am I talking about? I'm so sorry. Oh my gosh, I'm so sorry. You want this in terms of secant of x. I think I was saying that wrong the entire video, but it'd be secant squared of x times 1 plus, or I'm sorry, it'd be secant of x would, or tangent of x would be secant of x minus 1, right? Let me check that. Yeah, okay, sorry about that. So it'd be secant squared of x minus 1. I'm really sorry for you guys watching these videos today. My brain is like not working, but I really want to finish these videos. So multiply these out, you get secant squared, or secant to the 4th of x minus secant squared of x times secant x tangent x dx. And now we can do U substitution. If we make u equal secant of x, then du equals secant of x tangent of x dx. So that's going to cancel out, and you get u to the 4th minus u squared du. And then that'd be 1/5 u to the 5th minus 1/3 u to the 3rd plus c. Or 1/5, I hope you can see this, it's like at the very bottom, 1/2 secant to the 5th of x minus 1/3 secant to the 3rd of x plus c. And that is how trig works into this unit in one video. I hope you understood it.